At a pickle mega factory like the kind Vlasic is known for, the process starts with a race against biology. Cucumbers keep respiring after harvest. Enzymes keep working. And the skin is covered with field microbes that will either become helpful fermentation partners or expensive spoilage. Depending on how fast the plant takes control, cucumbers arrive from contract farms in bulk bins or trailers, usually within hours of harvest, because firmness is the entire game. The receiving station weighs every load, logs the field and harvest time for traceability, and pulls samples to measure temperature, size distribution, and defect rate. Even before washing, the plant is already doing process engineering. Lots with smaller cucumbers get routed to whole pickles. Larger and straighter fruit becomes spears, and inconsistent lots get diverted to chips or relish. Where cutting hides minor cosmetic defects but still demands crunch, the first mechanical objective is gentle handling, because bruises turn into soft spots during brining. Instead of dumping cucumbers onto dry belts, many facilities use water flumes as transport channels. Water supports the fruit, reduces drop damage, lets the plant move huge volumes through pipes and troughs with controlled flow. The flume system is engineered with screens and rock traps to catch field debris before it reaches pumps. Because a single stone can shred impellers and send plastic and metal fragments downstream, washing is not one step. It's a staged cleaning system built around soil removal, microbial reduction, and water efficiency. Cucumbers pass through spray bars, rotating drum washers, and brush beds that scrub the skin without cutting it. Water is usually countercurrent, meaning the cleanest water touches the cleanest cucumbers near the end of the line, while dirtier water is used at the start. Chemical dosing is automated. Oxidizers like peracetic acid or controlled chlorine systems reduce surface microbes, while pH and ORP sensors keep sanitizer strength. It's inside a narrow window, so it's effective without damaging equipment or leaving residues. After washing, the plant shifts into high-speed grating. And this is where millions of cucumbers becomes a machine problem instead of a labor problem. Roll graders and sizing belts separate cucumbers by diameter and length using adjustable gaps, rotate rollers, and calibrated speed differentials. Modern lines add machine vision to catch defects humans would miss at speed. Cameras and structured lighting detect deep scars, blossom and rot, and yellowing that signals over maturity. Defective fruit is kicked out with air jets or diverter gates in milliseconds. Because allowing soft cucumbers into fermentation tanks doesn't just ruin one jar, it can destabilize an entire batch. Now the process splits depending on the product style. There are two dominant industrial paths. Fermented pickles, where lactic acid bacteria create acidity over time, and fresh pack pickles, where vinegar provides acidity immediately and heat processing locks in shelf life. Mega facilities often run both because the market demands different textures and flavors, and the equipment is designed to switch recipes without losing throughput. For fermented pickles, the next stop is bulk brining. Cucumbers are loaded into large fiberglass, concrete, or stainless tanks, sometimes outdoors, sometimes in controlled rooms, and submerged in salt brine designed to pull water from the cucumber and suppress unwanted microbes. Brine concentration is not guessed. It's measured with conductivity and density, then adjusted automatically with salt addition and circulation pumps. The plant wants enough salt to prevent spoilage organisms and softenings, but not so much that the cucumber dehydrates into a hollow shell. Fermentation itself is microbiology under industrial control. Naturally present, lactic acid bacteria can drive the process, but modern operations often inoculate with selected cultures to reduce variability and shorten cycle time. Temperature is managed because fermentation rate and flavor profile depend on it. Too warm, and you get gas production and bloating. Too cool, and fermentation stalls. pH probes and titratable acidity tests track the acid curve, because a stable pH below 4.6 is a key safety threshold for shelf-stable acidified foods. And it's also a quality indicator for flavor balance. Crunch is engineered, not wished for. Calcium chloride is commonly used to strengthen pectin structures in the cucumber cell walls, proving firmness through the entire shelf life. Enzyme inhibitors and careful control of fermentation conditions limit pectinase activity, because pectin breakdown is the fastest route to a mushy pickle. Many plants also manage dissolved oxygen and headspace in bulk tanks, because oxygen can drive surface yeasts that create off flavors and slimy films. Once fermentation reaches the target acidity, cucumbers are not ready for jars yet because they're sitting in high salt brine. The next mechanical challenge is desalting and equalization. Cucumbers move through rinsing flumes or soak systems where salt diffuses out to a target level. Water use here is controlled aggressively. Staged tanks, countercurrent flow, and reuse loops keep operating costs down. And salt-laden wastewater is routed to treatment systems designed for high salinity loads. Fresh pack pickles take a faster route. Instead of weeks in fermentation, washed and grated cucumbers go directly to cutting and packing, then get acidified in the jar with vinegar brine. This path depends heavily on heat processing to achieve shelf stability while preserving crunch. So the factory tunes brine chemistry and pasteurization curves carefully to avoid overcooking. Cutting is high speed and geometry driven. Whole pickles require intact skins and uniform diameters to pack efficiently. Spears and chips are made with stainless multi-blade cutters that index each cucumber into consistent slices at high throughput. Blade sharpness is monitored because dull blades crush tissue, releasing enzymes and increasing softening during storage. The plant also manages seed cavity exposure. Larger cucumbers with bigger cavities are better suited to chips or relish, while spears are chosen for tighter interiors that hold shape. Before packing, cucumbers and spices are staged in controlled hoppers and feeders. Dill, garlic, mustard seed, pepper, and other seasonings are dosed by volumetric or gravimetric systems. And the recipes are locked by barcode verification, so the right spice tote matches the right production run. This matters at mega scale because a single wrong spice load contaminates thousands of jars with the wrong flavor profile and triggers rework or disposal. Jar handling is its own engineered line. Empty glass jars are depalletized, inverted, and blown out with filtered air to remove dust. Many lines rinse or sanitize jars, then feed them into star wheels that index each jar under the fillers. Glass is unforgiving at high speed, so conveyor guides, accumulation tables, and anti-tip systems keep jars stable while maintaining constant flow into the filler. Packing cucumbers into jars looks simple until you do it at industrial speeds. For whole pickles and spears, automated packers use pocketed conveyors and mechanical fingers to orient product and hit a target count per jar. Vision systems verify fill level and orientation, because a spear protruding above the liquid line becomes a discoloration complaint later. For chips and relish, volumetric fillers portion product by weight, and inline checkweighers correct drift by adjusting fill cycles rather than stopping the line. Brine preparation runs continuously beside the packaging line, and it's controlled like a beverage plant. Vinegar strength, salt content, sugar, and spices are blended in jacketed tanks with high shear agitation, then filtered to protect valves and nozzles. Inline pH sensors confirm acidity, because in an acidified food, pH is a safety control point, not just a taste preference. Many plants preheat brine to improve heat penetration in the jar and to help pull air out of the cucumber tissue, improving vacuum formation after sealing. Filling is a coordination problem. Solids must be in the jar before liquid, and the headspace must be correct so the lid seals and vacuum holds. Liquid fillers use level control or flow meter dosing, and they're tuned to avoid splashing because brine on the rim can compromise seal integrity. Immediately after filling, jars pass through a steam flow or vacuum channel that displaces air in the headspace, improving the final vacuum and reducing oxygen that would fade color and dull flavor. Capping is a torque-controlled mechanical operation. Lids are fed from hoppers, oriented and applied by capping heads calibrated for consistent torque. Too little torque gives microleaks and early spoilage. Too much torque cracks glass or distorts the lid liner. Inline cap inspection checks lid presence, skew, and sometimes vacuum levels, rejecting defects automatically to prevent a single bad cap from turning into a customer complaint and a traceability event. Heat processing is where shelf stability is locked in, and it's optimized for texture. Many pickle lines use tunnel pasteurizers, long, multi-zone systems that spray jars with progressively hotter water, hold them at a target temperature for a validated time, then cool them gradually to prevent thermal shock. This is heat transfer engineering. The plant must heat the cold spot inside the jar enough to control spoilage, microbes, while minimizing total thermal load that would soften the cucumber. Continuous monitoring tracks water temperature, belt speed, and residence time. Any deviation can trigger product holds because the process must match its validation. Some products use hot fill hold rather than a full tunnel pasteurizer, depending on the recipe and packaging. In that approach, hot brine and hot product achieve the necessary thermal treatment in the container. Then the jar is inverted or held for a set time to sanitize the lid area. The benefit is less equipment and faster line speed. The risk is tighter dependence on temperature control and consistent fill conditions. After thermal processing, cooling is managed to protect both product and glass. Rapid cooling can create thermal stress and breakage, while slow cooling keeps the product in a high-temperature zone that continues softening. Multi-zone cooling steps bring jars down in stages, and water is filtered and treated to prevent biofilm growth inside the pasteurizer. Labeling and coating are not cosmetic. They are traceability. Inkjet, or laser coaters, print lot codes that tie each jar back to a specific cucumber lot, brine batch, and process record. Vision systems verify code readability and label placement. Because unreadable codes break, traceability chain that regulators and retailers require. Case packing and palletizing are where the plant proves it's a factory, not a kitchen. Jars are collated into cases by robotic packers. Cases are sealed. And palletizers stack loads in patterns designed for stability and warehouse efficiency. Stretch wrappers apply controlled film tension to prevent shifting without crushing corrugate. And finished pallets often pass through weigh scales to confirm count accuracy. Before shipping, quality assurance runs in parallel with production. Constantly sampling for pH, salt, bricks if sweet styles are made, and texture metrics like firmness. Many plants use texture analyzers that measure force required to bite through a pickle, because crunch can be quantified and tracked over time. Brine, clarity, color, and spice distribution are checked to prevent haze and settling. Microbiological testing verifies that sanitation and process controls are holding, especially for yeasts and molds that can survive acidic environments if oxygen is present. Sanitation is engineered around sticky brine, organic residues, and corrosion risks from salt and vinegar. Clean-in-place systems circulate detergents and sanitizers through brine lines and fillers, while tunnel pasteurizers and conveyors are cleaned on scheduled cycles to prevent biofilm buildup. Stainless selection, gasket materials, and drain design matter here because salt accelerates corrosion and creates hidden harborage points if equipment is poorly designed. Water and waste management are major engineering challenges in any pickle mega facility. Wash water and brine losses carry high organic load and high salinity, which complicates wastewater treatment. Plants use screening, dissolved air flotation, and biological treatment tuned for variable pH and salt. Some operations recover salt from spent brine, reuse water in non-contact stages, and capture heat from pasteurizer, discharge water to preheat incoming zones. Cutting energy per jar? What makes a mega pickle factory high-tech? It's the combination of agricultural variability and industrial consistency. Cucumbers change daily with weather and harvest timing. Yet the factory must deliver the same crunch, the same acidity, and the same flavor in every jar. That consistency is built with optical grading, controlled brine chemistry, validated acidification targets, precision thermal processing, and automated inspection that catches defects at line speed. By the time a jar leaves the palletizer, the cucumber has been mechanically handled, chemically stabilized, biologically controlled, thermally validated, and digitally traced because scaling pickles to millions of jars is less about tradition and more about engineering. Every variable that makes a cucumber either crisp or disappointing